In this video we're solving more radical equations, but we are focusing on solving equations with two radicals, okay? And so in not all instances, but in some instances, when you have two radicals in an equation, that is, I have, say this first equation here, it says solve for x, and we get the square root of 3x plus 2, all of that minus 2 times the square root of x. All of this equals 0. So essentially, we're saying this square root here minus this square root here. You notice that there are two terms that have a square root, okay? So our goal is going to be this. You know, we say goal. If at all possible, we're going to put one square root term on each side, okay? On each side, okay? And then we're going, you know what? Let's just put it this way. Put one root term on each side, and then we're going to raise both sides to the appropriate power. To eliminate our root, okay? So to eliminate the root. Now, you know, a few things I'm going to point out in this video. First of all, this is only going to ever work if you have two terms and they both have a root on them, okay? So the first thing we're actually going to do here is this. We're going to add this 2 times the square root of x to both sides. Now, I could have, to get one of these radicals on each side, I could have subtracted this from both sides, but then you'd have a negative value on each side, and I'd rather just do this. So what I want everybody really to see here is this. I'm essentially just moving this entire term over to here, and we end up simplifying out to be this. The root of 3x plus 2 is still on the left side, whereas we put 0 plus 2 root x. You add these together, you get 2 root x. So now that we have both roots on each side here, what we're going to do is we're going to raise both sides. And we're going to raise it to the appropriate power. So another thing that I want to mention here is this. This only ever works is, you know, if they have the same roots, the same indices. These both were square roots, okay? So if this was a square root and this was a cube root, you can see how squaring both sides wouldn't really be effective with the cube root, or cubing both sides wouldn't really be that effective with the square root. So in this case, we are going to square both sides and talk about what we get left here. The essential bits of what we have left over here are 3x plus 2. But over here, the important thing to recognize here is this. This is 2 to the first times the square root of x. So when we take 2 to the first to the second, we actually have to do this on both of these terms. We get 2 to the second, so we really get 4. And we say times the square root of x squared, which is really just x. So in the long run, we say, well then 3x plus 2 is equal to 4x. Now all we want to do is solve for the unknown. Okay. So the only thing we have left to do is solve for the unknown and check the answer that we get. So we're going to go ahead and solve for the unknown now. I'm going to go ahead and subtract 4x from both sides just to get all my x's on one side. So we get negative x plus 2 equals 0. We'll subtract 2 from both sides. So we get this here. We get negative x equals negative 2, which basically implies that positive x equals positive 2. And again, I want to check this here. So if I check this out, we say 3 times, in this case, 2 plus 2 minus 2 times the square root of x, which is 2, equals 0. Then what we really get is this. We get the square root of 6 plus 2 is 8, minus 2 root 2 equals 0. And remember, the square root of 8, that's the same thing as the square root of 4 times 2, minus 2 root 2 equals 0. So essentially, on this first one here, we say, well, the square root of 4 is 2. So really what we get is this. We get 2 root 2 minus 2 root 2 equals 0, which is 0 equals 0. Okay, so things check out. That is our solution value. So again, let's try this guy here. The first thing we want to do is get the roots on both sides. If there are two roots, you know, then we're going to go ahead and put this term over here. So that means we're going to add 3 times the square root of 2x to both sides. So add 3 times the square root of 2x to both sides. And we get left with this. We get the square root of 4x plus 28 on the left side. And on the right side, we have a positive 3 times the square root of 2x. So now that we've done this, we can go ahead and square both sides. In this case, we want to square. And we get left with 4x plus 28 on the left side. And on the right side, we get left with, now, this is 3 to the first to the second. So that's 3 squared, so that's 9. And then we get the square root of 2x squared, so that's 2x. So we get these values here once we apply the square here. So we get 4x plus 28 on the left side. On the right side, it looks like we have 18 x's. And so now we just need to get all our x's on one side. I think it's most convenient actually to subtract 4x from both sides on this guy here. And we get left with this. You know, I'm going to have to transplant it over here. We say 28 on the left side, and then 18x minus 4x would be 14 x's. And if we divide both sides by 14 now, not that I have to get nice whole number integer values, but we did get x equals 2. And again, we want to check this. So we say 4 times 2 plus 28 minus 3 times, 2 times 2. 2. And we said this equals 0. So let's simplify this. We get the square root of 8 plus 28 is square root of 36. minus 3 times the square root of, looks like 4 here. So square root of 36 is 6. And we say minus 3 times 2 equals 0. So we get 6 minus 6 equals 0, and 0 equals 0. So yes, the solution. So that is how you deal with equations having two radicals, if at all possible. If they are the same indices, then throw one on each side, and we'll just raise both sides to the same power. Cheers.